Hello, beautiful people, and welcome. We're going to be going over your Module 11 in the Integrated Math 1. I believe this is Unit 4, maybe? Doesn't matter. We're going to be using system of equations by graphing. We're going to be doing system of equations by elimination, and then we're going to be doing system of equations by substitution. So this is a review. We're going to just be taking some notes. And so then we can be successful on our Module 11 quiz, our test, our final. Basically, we'll just be able to solve all of the system of equations. Okay, so the first thing that we are going to do is we're going to review graphing. Now, when you are graphing system of equations, there are always three types of solutions. So there are three solutions. So when graphing, you're gonna, have an X and Y coordinate system. So option number one, when you're graphing, is to have two lines that intersect somewhere, and then your answer is where they intersect. So you can have one solution, and that would be, let's say this is 4. So then your solution would be something like 2, 4. This would be your answer. Now let's say you got two lines that don't intersect, that no matter how long they go in either direction, they will never be touching. So this is still asking the question, where do they intersect? The answer is, well, they don't intersect, therefore there is no solution. What's really great about these is that if you have it in y equals mx plus b form, that your slope will be the same in both equations. Okay, so technically, if you look at your equation and it's in y equals mx plus b form, the m value, if the m value is the exact same, then there should be no solution. The b value or the y-intercept will be different. The only thing that will be the same would be the slope. Ooh. Let me get up. My lights just turned off. That was that glitch. We have my, there you go. And we're back on. Right, so we have one solution, which is a point. You will need to have it in a coordinate system, so you'll have your x and your y value. Your second solution is no solution. And your third solution would be something that if you have a line and you have another line, but it's the same line. So both lines are the same line. They're on top of each other. Well, our question is the same. How many times do they cross or how many times do they touch? Well, they touch all the time. So the answer to that one would be we have an infinitely many solutions. Now I'm abbreviating because mathematicians are lazy. So if I can't abbreviate, I will. So infinitely many solutions. And so for infinitely many solutions, that's different from no solutions. If you have it in y equals mx plus b in slope-intercept form, you will notice that your slope and your y-intercept, they will be the same for both equations. Okay, that's for graphing. Got three different answers that it could be. So let's do an example. So example. So let's do x minus y is equal to 1. X plus y is equal to 3. Now, some of you are going to want to start to eliminate things. Don't do it. where we have to solve this by graphing. If on a test or in any sort of assessment or quiz, if it doesn't tell you the method you have to use, then have at it. Do whatever method you want. You got graphing, elimination, substitution, that will, make you be successful on this question. But if they tell you the method, for example, you need to graph this, you must do what they ask. Okay, notice how these are not in y equals mx plus b form. That, in my opinion, would be the easiest way to graph this because you would have your intercept and your slope. If you want, you can do your x and y intercepts by substituting for your y 0 and then x 0, but I will choose to do y equals mx plus b form. Okay, so I'm going to subtract x. So here I have negative y is equal to negative x plus 1, but I need to get rid of this negative, so I'm going to multiply everything by negative 1. So I have y is equal to x minus 1. I am distributing that negative 1. Same thing for the bottom one. Let me change colors. I'm going to subtract x both sides. So this gives me y equals negative x plus 3. And so that one, I'm going to rewrite it so they line up. That one's done. So I need to graph these. Now again, I'm going to get my ruler because when you're graphing, you want to get as precise as possible. This might be a little bit difficult to see because I am freehanding it. But let's see, maybe we can get super duper lucky. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, so slope. What number is in front of x? It is 1. How do we make that into a fraction? We put a 1 underneath that. Our intercept is negative 1. And specifically, it is our y-intercept, so we want to indicate it on our y-axis, so we need negative 1. There it is. Now this is our slope, 1 over 1, so I go up 1 over 1, up 1 over 1, and then I'm going to use my ruler to connect. I'm going to try to make it as perfect as I can. Again, I am human, so pretty much probably won't be perfect, but I'm going to try at least. There it is. Okay, now we're doing the same thing for the other equation. Here is my y-intercept. What number is in front of x? It is 1. How do I make that into a fraction? Put a 1 underneath that. So my slope is negative 1 over 1. So I need to find 3. 1, 2, 3. And then I'm going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And I'm super duper happy because I already see that I'm going to have one solution. And my lines are going to intersect at one point. And that point is this point here. So this is not your answer. So if you leave this on an assessment, this will be marked wrong. You may get pity points. Your teacher might feel, sorry for you and be like, oh, they did so much work, but this is not the answer. The answer for one solution looks like this. It has to be an ordered pair. You have to give me an x and a y value. You must group it. Those two numbers have a relationship with each other, so you must put them in parentheses. So the x value is 2, the y value is 1. You group them in parentheses, and this is your answer. Okay. Again, one solution, no solution, many solutions. Let's move on to elimination. Now, elimination is everyone's favorite method because it feels so good to cancel stuff out and cross stuff out. So elimination. I don't know what happened to that N. That should be an N. Elimination. Elimination, again, because it is a system of equations, a method of solving system of equations, there are 3 solutions. So when you are solving things, you can have something like x equals a number, y equals a number, equals, let me try that again, y equals a number. So your solution is going to be x comma y, whatever those numbers are. For example, 3, 4, that would be an answer. If you have no solution, you will get a false and always false statement. No matter how you look at it, the statement will always be not true. For example, if you get 5 equals negative 13, ask yourself, does 5 ever equal negative 13? The answer is no. Therefore, this statement is not true, and your answer is no solution. On the opposite of that, on the other hand, you have the infinitely many solutions. So for infinitely many solutions, we will get an always true statement. And so that will look something like, I don't know, 3 equals 3. Negative 5 is equal to negative 5. Does 3 equal 3? Yes. Does negative 5 equal negative 5? Yes. So if you get something like that, your answer is infinitely many solutions. Now, this is the same 3 solutions for substitution. Doesn't matter which method you use, you will have 3 solutions, but they will look like this for both elimination and substitution. All right, let's do an example. So let's do example. Let's do negative 3x plus y is equal to 11. 12x plus 4y is equal to 20. And in this method, again, they have to tell you, or else you can choose whatever method you want. I would like elimination. So for elimination, we have step number 1. Identify which variable you would like to eliminate. It doesn't matter. My recommendation for all my kiddos, choose the easy one. Now your easy might be different than my easy, but choose the one that you believe is going to be the easiest. I also recommend looking for patterns, like looking for a variable with the same number. So if I have a 4 and a 4, maybe that's the variable I should cancel. If I have a 12 and a 12, maybe that's the variable I should cancel. Look at those numbers before you choose a variable, so that way when you make that decision, when you choose or select a variable, you can save yourself some steps if you can. Now, also, step number 2 is once you choose a variable, make sure the numbers match up. If the numbers don't match, then you have some work to do. So I'm going to choose y. Why do I choose y? I don't know. It's because I want to choose y. Doesn't matter. Because I have chosen y, I'm going to look at both of these. So I have y and 4y. I need the numbers, the coefficient in front of my variable to be the same. Okay, so somehow I need to get this right here to be a 4. So what I'm going to do is I'm going to take the entire equation and I'm going to multiply it by 4. Now when I multiply by 4, I am multiplying every single term by 4. So that will give me 4 times negative 3 is negative 12x. Then I have plus 4y is equal to 44. Then I have the bottom one. The bottom one did not change, so I'm just going to copy that down. Now, I'll be honest, right now I'm having a little bit of anxiety because I'm looking at these two numbers, they're the same. These two numbers, they're the same. So it's making me feel a little anxious, but that's okay. We're going to walk through this. Here's the thing. We have chosen a variable. Which variable did we choose? We've chosen our y. So now you look at the sign. If they are the same, if they are both positive or both negative, you're going to add all the terms together. Now, if you had terms that are the opposite, so the number is the same, but one is positive, one is negative, then you must, oh, I think I just misspoke. Let's try this again. Let's make a thinking bubble. If the signs, if you have a plus and a minus, you're going to add. If you have the same sign, so a minus and a minus, or a plus and a plus, you're going to subtract. I ran out of space. That's supposed to say subtract. And the reason for that, let me get rid of my pluses. We want to cancel or get rid of our y. So 4 plus 4 is 8. Well, 8 is not 0, so it doesn't achieve what I would need it to be. So the only way that I can get rid of 4 and 4 if I have a minus. So 4 minus 4 is 0. So then all of these have to be the same minuses. So negative 12 minus x minus 12x. And then we have 44 minus 20. Now I'm writing it down like this so you guys can catch this step here. This is not negative 12 and positive 12. This is negative 12 and a negative 12. 0 you don't have to write. That feels really good. You can just cross them out. So negative 12 and negative 12 is negative 24x. 44 minus 20 is 24. Divide by negative 24 both sides. X is equal to negative 1. Now some of you are going to get super duper excited and say, we are done. No, you're only halfway there. So let's continue. Once you have found the solution for one of your variables, you're going to have more decisions to make. One of those decisions is which equation do you choose, 1, 2, or 3, to substitute the solution that you got to find out what the other variable is equal to. So I'm going to choose again the top one. Why? I don't know. Just because that's the one that I've chosen. It doesn't matter. Choose whichever one you want. I'm going to rewrite it. Maybe I chose it because I see smaller numbers. I like smaller numbers. So I'm going to substitute in for x. Always use parentheses. If you don't use parentheses, you are running into an area that you might make a mistake in. So negative 3 times negative 1 is positive 3. I'm going to subtract 3 both sides. Y is then equal to, I'm counting backwards. So when I do this, I don't count 11, 10, 9, 8. I do 9, 10, 11, 12. That's not it. 8, 9, 10, 11. So it is 8. Are you done? Some of you may think you're done, but you're not done. This is only your work. This is not your answer, remember? You have 3 answers it may be. It can be this answer, it can be this answer, or it can be this answer. So, did we get a false statement? No. Did we get an always true statement? No. So the only answer that you can have is 2 numbers separated by a comma in parentheses, which are a coordinate point. So we have our answer as negative 1, 8. And that is your answer. That is where, if we were to graph these 2 lines, that would be their point of intersection. Now, I'm going to do the same exact problem, but now we're going to do, guess what method? Substitution. And let's see if maybe substitution would be easier or maybe it'd be harder. I don't know. Let's find out. Let's do this together. So I'm going to rewrite the question that we had. I'm going to rewrite it. The original. So negative 3x plus y is equal to 11. 12x plus 4y is equal to 20. Step number 1 is choose an equation. So which equation would you like to work with? Choose the easier one. I'm going to select this one, the top one. And the reason I'm selecting it is because I'm noticing smaller numbers. Also, when you're doing substitution, choose the equation that doesn't have a number in front of one of your variables. That will help you. If there is no equation like that, that's okay. Just choose whichever one looks easier. But if you have an equation without a number in front of your variable, that helps you. Okay, so I'm going to rewrite this. I have negative 3x plus y is equal to 11. I'm going to solve for y, meaning I'm going to get y by itself. So I'm going to add 3x to both sides. Cancel these out. So I have y is equal to 3x plus 11. Okay, now mathematicians are kind of lazy, right? So we're not really creative with the way we name things. So guess what we're going to do in the method called substitution? Exactly, we're going to substitute. So the reason we chose an equation and we solved for a variable is because we need to substitute this right here into our other equation to solve for the other variable. So let me show you what I mean by this. I'm going to take the equation I did not use. So I have 12x plus 4y is equal to 20. I'm going to take what I solved for and I'm going to substitute it into the variable that I solved for. So I solved for y. This is y. So then I'm going to substitute in for it. So now I have 12x plus 4. And instead of writing y, I'm going to write what y is. Y is 3x plus 11. And I'm going to finish off the equation. Now I have to distribute my 4. So I have 12x plus 12 plus 3 is 12x plus 44 is equal to 20. 12x and 12x, that's 24x plus 44. I'm combining like terms, so get all the x's grouped together. I'm going to subtract 44 both sides. I'm running out of room. Let's see if I can squish this in. So I have these crossed out. 24x is equal to negative, oh, what is this? Negative 24? Yes? Oh, that's not right. What should this be? Is that right? I'm doubting myself. I'm doubting myself. Is this in fact 24? I'm doubting myself. Let's see. If I add 20 to 24, it is 24. See, even teachers doubt yourselves, you know? We're just human. Okay, so divide by 24. All right, so x is equal to negative 1. So far, so good. Again, it's the same problem, so our answer should be the same. Excuse me. I apologize for that. All right, so then same thing we did from elimination to substitution. Once you're at this step, you're going to substitute in x. Excuse me, we're going to substitute negative 1 in for x. Again, I'm going to choose this top equation because it looks smaller, it looks easier, so I'm going to rewrite it. Substitute my negative 1 for x. This is what? 3 plus y is equal 11. I'm going to subtract 3. And again, running out of room. These cancel out. So y is equal to 8. Again, I'm going to double check by counting up. So 8, 9, 10, 11. Yep, that's correct. Is this your answer? No, it is not. So your answer is a coordinate point with your x and your y. All right, guys, this has been fun. Good luck on your assessment.